fractions. And just like when we subtract whole numbers, sometimes that number on top is not larger. Okay? And when that happens, when we subtract whole numbers, what do we have to do? We have to borrow and regroup and look at our numbers a little bit differently, right? Okay? So when we are talking about fractions and mixed numbers and we're subtracting mixed numbers in our two numerators, if our top numerator is smaller than our bottom numerator, no, yes. If the top is smaller than the bottom, just like when we're subtracting whole numbers, we're going to have to go in and we're going to have to borrow. Okay? So I'm going to show you a sample problem where we're subtracting mixed numbers where we do not have to borrow, just so that you can see that process. It's going to be just like when we added fractions, and then we went from adding fractions to adding mixed numbers. The only extra step was worrying about those whole numbers. Subtracting fractions is just the same. You already know how to subtract fractions. We're just throwing one more step in there. Okay? So, if you are a doodler, please put your stuff down and make sure that your attention is up here so that you can watch. Okay? Gabe, are you comfortable back there? Or you want to come up here like you did yesterday? Okay. So let me show you one where maybe we don't have to worry about borrowing. If I can come up with one. Top of my head. Okay, just like when we add fractions, our first step is to always have common denominators. And I know some of you like to write and work them with me, but I would prefer that you watch these two. Then I'll give you a chance to work one with me. Okay? So my first step is finding common denominators. I can do that one of two ways. Tell me one way I can do that, Chelsea. I can multiply my two denominators, and that's going to give me a common denominator. What's another way I could do it, Landon? I could list my two denominators and find the least common multiple, right? Does Mrs. Wiseman care which way you do it? No. Okay, I care that you get the correct answer. So we're just going to choose the method here of multiplying our two denominators. 3 times 5 is 15. Okay. Then I have to create my equivalent fractions. 5 times 3 gives me 15, right? Okay, and if I multiply the bottom times 3, Chloe, what do I do to the top? I multiply it by 3. 1 times 3 is 3. Here, 3 times what gives me 15, Caleb B? 3, 5. Okay, if I multiply the bottom times 5, what do I have to do to the top? 2 times 5 is? I did good. Okay, now I know how to subtract fractions. Okay, you've already had that lesson. I take my numerator at the top and subtract my numerator from the bottom, right, Alexa? 10 minus 3 is 7. What's my denominator, Taylor? 15. Okay, just like yesterday when we were adding fractions and I had you draw a box around those whole numbers. Okay, again, that's just a technique I like to use to remind myself I've got to come back and look at those whole numbers. Okay, so I did the subtraction part. I subtracted 10 minus 3 and got 7, and 15 stayed my denominator. I can't forget about my whole numbers. That's the only extra step so far. 4 minus 2 is? Here would be my final answer. 7 over 15 is simplified because 7 is a? Great. Okay, so the only real difference between adding and subtracting fractions so far is, our mixed numbers so far is, make sure I follow the sign, right? Okay, I can guarantee you one thing. So please, prove me wrong. The biggest mistake any of you will make when adding and subtracting fractions is not paying attention to the signs. You will not pay attention to if you're adding or if you're subtracting. It won't be a process error that you make. You'll know the steps. You'll just add when you're supposed to subtract or subtract when you're supposed to add. So pay attention to those signs. Please prove me wrong. Okay? Now, let me show you a little bit harder example here where I have to do some regrouping. This is the one that's going to have that extra step on it. So if you weren't paying attention to that one, please pay attention to this one. And if you are, good job. What?
What do you ever, if you have to
whole number may change if you have a mixed number that you have to add or subtract from it. Okay, so if I have 7 and 1/4 minus 3 and, let's just keep it simple with our denominators at this point. Okay, so I have 7 and 1/4 and I have 3 and 1/2. How many of you know when you think about fractions that you understand if I have a fourth of a pizza, I have less than if I have a half of a pizza? How many of you does that make sense to? How many of you would rather have a fourth of a pizza over a half of a pizza? Less is more, huh? Or would you rather have half a pizza and have more, and then you can have leftovers, put it in the refrigerator, and eat for breakfast? That's weird. Okay? All right. So, focus up here. This is the one where we have to regroup. This is the extra step that may confuse you a little bit, which is why we're going to spend 2 days on this. Okay? I still have to follow the same step of finding common denominator. So when I look at 4 and 2, what could be a common denominator, Leslie? Could be 4, could be 8, could be 12. Okay? But we're going to use 4. Okay, I still have to create those equivalent fractions. So 2 times what gives me 4? 2 times 1 is? Okay, 4 times what gives me 4?
1.
1 times 1?
1.
See my problem?
Yeah.
What's my problem up here, Emily? If I have 1 pencil, can I give you 2? No. Okay, so here's where that extra step is going to come in. At this point, you have to make sure that your numerator on the top is larger than your numerator on the bottom. Problem major here, right, Gabe? Because it's not. So what do? We talked about we have to do the same thing as we do with whole numbers where we have to borrow. Okay, so I'm going to come all the way over here to my 7. Okay, follow me. Before I show you the next step, here's what I want you to think about. If I have something like 7 over 7, that's equivalent or equal to what? Okay, if I have 19 over 19, that's equal to or equivalent to what?
1.
Okay, so any number over itself is always equal to 1. So I'm going to borrow 1 from 7. 7 is going to become 6. You're used to that step, right? When you borrow from a whole number, it goes down 1. Okay, but I'm going to use this technique where I can write a number over itself because that's going to be equal to the number that I'm borrowing here. Okay? And I have to add it to this part here. Just like if I had, I don't know, 13, let's make that 23, minus 17. Okay? Look at this whole number for me, if you will. If I'm doing 23 minus 17, I can't take 3 and take 7 away, right? So I have to borrow from this 2. It becomes a 1. And then that 1, we're really adding that over here as 10 individuals, right? So now I have 13 versus 3, right? So we're taking that part that we're borrowing and we're sharing it somewhere else. I'm going to do the same thing up here, okay? And I'm going to share it as a fraction. If I want it equal to the one that I'm borrowing, I have to use the same numerator as denominator, right? And when I think about adding fractions, what makes adding fractions really easy? It's really easy to add fractions when they already have common denominators, right? I don't think about it very much. So that 1 that I borrowed from that 7 to make this whole number a 6 now, I'm going to add it over here. Since this denominator is already a 4, I'm going to add it as 4 over 4. Why would I add it as 4 over 4? What do you think, Caleb? Okay? Because then I got to do a little addition problem here. 1 plus 4 is, keep the same denominator when we add fractions, right? This here bottom fraction is not going to change. It's 2 over 4. Okay? Now I have a larger number on top than I do on the bottom. Okay? The one that I borrowed from here, I'm sharing it right there. I'm adding it right there as a fraction over itself, a number over itself. Okay? And then I'm adding these two fractions just like I add that one whenever I had my 23 minus 17. Just how I add that one here as 10 individuals to make it 13. I'm doing the same thing here by adding 1 plus 4 to get 5. Okay? I'm going to do several examples, so if you're not understanding, that's perfectly fine. I don't expect you to yet, but I do expect you to make sure that you're following along. Okay? Now, I can do 5 minus 2, which is, keep the same denominator. 6 minus 3 is, this would be my final answer. Okay? I'm going to do one just a little bit quicker so that I'm not talking as much to get through it. So that I'm not talking as much, and maybe seeing it all together will help you a little bit. Okay, so if I have 5, and again, I'm going to keep the denominator small so that you can think about this. Okay, and I have 1 and okay, 1 and 4 fifths. Again, I'm subtracting. I like to box my whole numbers. Okay, my first step is to find common denominators. That step has not changed, right? Okay, how do I get from 5 to 15? I have to multiply by 3. So I have to multiply my 4 by 3. 4 times 3 is? How do I get from 3 to 15? I have to multiply by 5. 5 times 2 is? Here's where my problem comes in. Again, my numerator is smaller than my numerator on the bottom. Okay, here's where the borrowing comes in. So if you haven't tuned in yet, now would be the time to tune in. Okay, so I'm going to come all the way over here to my whole numbers. Gabe, what's my 5 going to become? 4. I have to share it over here because I need to make this denominator bigger. I'm sorry. Erase that from your memory. I need to make this numerator bigger. Okay? So, the one that I borrowed from here, I'm going to look at this denominator. It's 15. The one that I borrowed, I'm going to write here as 15 over 15. Then I'm going to add these two parts. 10 plus 15 is, keep the same denominator. This fraction is not going to change. I still have 12 over 15. Now, I can take 25 minus 12, right? What is 25 minus 12? Keep the same denominator. Then I go back over here to my wholes. 4 minus 1 is
3.
Giving me 3 and 13 over 15. It's this part here. And I understand that. But there's not another way that I can break it down a whole lot easier. What you're going to have to keep in mind is that you're going to have to do a small addition problem within your subtraction problem. Okay? So, tell me very quickly, would it help you to